Fox, hope you're all doing good. This video is a continuation of the Solaris 11 zones videos that I've posted on the YouTube playlist. In this particular segment about Solaris 11 zones, we're not doing anything too different from what we've already done. In the last two videos around Solaris 11 zones, we did see how we can configure, install and bring up a Solaris 11 zones in a Solaris 11 operating environment. In this video, we would probably make use of an existing zones configuration file to configure a zone rather than doing it by hand. Then we will also take a look at how we can clone a new zone from an existing zone. That will speed up the whole process of building a zone in a Solaris 11 operating system. In addition to that, we would also make use of the virtual network interface cards created on a stub in the Solaris 11 operating system. I would request you to please recall the concept around stub in Solaris 11. In case if you're not familiar with it, I would request you to please look at the Solaris 11 documentation or probably the Solaris 11 networking video segment that I've posted on the playlist that talks about stub, which is a private switch within a Solaris 11 operating environment. So in this segment, we would create VNICs on that stub and assign those VNICs to 3 zones that we would configure and install. That will make a private network within a Solaris 11 operating environment. As you can see from the diagram here, I have 2 machines, one that has a host name S11 desktop, and you can see the IP address is of the range 192.168.0.x. I also have second machine which has a host name S11-server with the same network address 192.168.0.100. So obviously S11-desktop can talk to S11-server because they are on the same network. Within the S11-server machine, we're going to create a stub, which is a private switch, create VNICs on top of the stub, and assign those VNICs to 3 zones that we would configure and install. Please pay attention to the IP address of the zones that you see on the diagram here. It's all of the range 192.168.1.x. So what we get is actually a private group of machines within a Solaris 11 environment. So like I said before, you're not going to see anything too different in this specific segment. If you are familiar with how to install, configure a zone, only thing that you would get to see in this is to configure a zone from an existing zones configuration file, create a zone by cloning an existing zone, and the network port that we would be assigning to the zone would be the VNICs that we create on a private switch. So without any further ado, let's go to the machine and start configuring it. I'm on a Solaris 11 machine. Maybe we can quickly look at the etc release file to see what is the exact release of the Solaris 11 I'm running. As you can see, I'm running Solaris 11.3. We can also list the zones that are running on this machine by using the command zoneadm list -cv. You could see that there is a zone already configured and installed, but it's not in the running state. We can also see whether we have any stub here. So dladm show-etherstub is the command that we could use to figure out if we have a stub on this machine. We don't have a stub, so we will configure a stub. Let's create a stub to start with. Remember, stub is a private switch on top of which we would create VNICs that in turn we will assign to the zones we would configure on this machine. So let's say dladm create -etherstub, name of the stub, we'll call it as stub0. Said we are not going to configure a zone from the scratch by using the zonecfg command. Instead, we would make use of the configuration file of zone A and create a zone using the configuration file. Later, we would clone the new zone from zone A. That will speed up the whole process. Unlike the IPS repository download, the time that we required when we install the zone from the image packaging system repository, you would recall was longer, but this time around, since we are planning to clone it from an existing zone, you would see the process completing a bit faster than the earlier versions. So let's go ahead and configure a zone from zone A's configuration file. Before I do that, let's look at zone A's configuration file. In fact, this information is coming from zone A's configuration file that's residing in /etc zones directory. I would exit out of this. Maybe we can go into the etc zones directory, look at the several templates that exist inside that directory, as well as the XML file of the zone A. Remember, we are not supposed to hand edit this file. Any modification you would like to make in this file is expected to be done using the zonecfg command. That's a recommended way of doing it. No harm in looking at what is there inside the file. It's the same information we were able to see when we used the info sub command with the zonecfg command. So we have a zone by the name zone A. It has a path zones/zone A. It will boot when the machine comes up. It's of the type Solaris. The other brand is Solaris 10 brand. If you're planning to have a Solaris 10 zone inside a Solaris 11 machine, that's when you have a Solaris 10 brand. Then you have the IP type to be exclusive, which means the port that you assign to this zone is going to be exclusive to that specific zone. And here in this example, net1 is a port that we have assigned to the zone. Let's go ahead and create a new zone or configure a new zone from this file. So let's clear the screen and configure a new zone from the existing zone. So this is the only zone that is currently configured and installed. We're going to save the configuration file of zone A, and we will create or configure a new zone using that configuration file. The command to do that is zonecfg -z zone A, export the configuration file to, let's say, zone A dot if you want to give a extension zone A.txt. So we have the configuration of the zone A exported to a file called zone A.txt under the / directory. Obviously we are not supposed to use the file as it is, because there are some configuration that are very specific to zone A. For example, the net1 port we have already assigned to the zone A. Obviously we can't use the same port for the other zone because the IP type stands to be exclusive. So let's edit the file, make the required modification, and then use the modified configuration file to configure a new zone. We're going to use our favorite editor to go ahead and edit this file. Of course, the first thing that I might want to change is to change the name of the zone here. I mean the zone path to, let's say, zone 0. Then we have the auto boot to true. Let that stay as it is. Auto shutdown, that's also fine. IP type, of course, is exclusive. Of course, the net that is added to the zone is net1. We're going to change that to let's say VNIC 0, because that's the port we would create on the stub. Now that we have modified the configuration file, let's save it. Remember, we do not have the VNIC 0 created yet on the stub. We can do that later also. It's just a zone configuration. It wouldn't really matter if the VNIC 0 exists or not. Let me run the command zonecfg -z zone 0 -f /zone A .txt. This time around we have managed to configure a zone just by exporting the configuration file of an existing zone, make appropriate modification, and use that modified configuration file. Similarly, we will do this for zone 1 and zone 2 as well. So let's go ahead and do that. We'll modify zone A.txt. Remember the modification, of course, the zone path needs to be changed, and of course the VNIC 0 is assigned to zone 0, so we will change the VNIC to VNIC 1. Let's change it to VNIC 1, save the file, run the same command again. Of course, the new zone name that we would like to use is not zone 0 but zone 1. Let's go ahead and do that. Now that we have done it, we now have 2 zones configured from the configuration file. We'll create a third one as well. Let's go ahead and do that. Change the zone path to /zones/zone2, and then we will change the VNIC to VNIC2. Save the file, run the same command. This time around we will change the zone name to zone2, and then we will run the zone ADM list -cv command to see there are 3 zones that we have managed to configure by exporting the configuration file of the zone A. So that was pretty simple. Of course, the configuration file for zone A is not a complicated one. It's a very simple configuration. It could happen this way, that you want to configure a very complex resource management within the zone, so you could have a template ready and then modify the template appropriately to configure as many number of zones as possible. Maybe you can even script it so that you can automate the whole process of zone configuration. Now that the zone 0, zone 1 and zone 2 are in configured state, the next step of course is to install it. You will remember from the earlier session that the installation is done by using a zone ADM command, zone ADM -z, specify the name of the zone and install. That's the command we use to install the zone. Remember also that the installation happens from the image packaging system repository. We don't necessarily have to do it. It takes a lot of time. We have a zone A ready. Thanks to the ZFS file system that is used as a root file system for the zone, cloning a new zone from an existing zone is a process that happens in a jiffy. Let's go ahead and do that, but before we do it, I think it is safe to create those VNICs in the stub. There are other ways of configuring VNICs to a zone without having to create it manually, but that's something we would look at later. What we would do in this specific segment is to create those 3 VNICs on the stub so that we can assign those 3 VNICs to the zone. So let's we have the stub already. We can verify that here. Show Etherstub. Let's create VNICs on top of the stub. The command, if you remember, is dladm create -VNIC -l on the stub 0. I want VNIC 0. I would run the command 2 more times, VNIC 1, VNIC 2. So each of this VNIC 0 is for zone 0, VNIC 1 is for zone 1, and VNIC 2 is for zone 2. The next step of course is to install the zone 0. Like I said, we're going to do that by cloning zone 0 with zone A. So let's clear the screen and run the command zone ADM -z zone 0 clone zone A. Remember, we will have to have this zone A down or halted or in installed state while performing the clone operation. If the zone A was running, it would have given a message that says you need to bring down the zone for cloning operation to take place. So now that you can see, it created a ZFS file system /zone/zone 0 under the R pool, and now the cloning is in progress. Of course, if we grab another terminal here and look at what's happening, I need to SSH to the machine where I'm running it. So let me do that. Let me su to root and look at the status of zone. You can see that the installation of the zone 0 completed. So how fast it completed, as you can compare it with the installation of the zone from the image packaging system repository. That was pretty fast. We'll do the same thing for zone 1 as well. Let's clone zone 1 from zone A, and while it happens very quickly, we would go ahead and look at what is the status of zone 1. It's in incomplete state. Remember again that if we install this from the image packaging system repository, you would see that it takes more time than in this scenario. Hence it's a good practice to have a template zone installed on your machine so that easily you can provision as many number of zones as you want by just cloning that template zone that exists on the machine. That's saves a lot of your time. So let's see what is the status of it. It's already completed the cloning operation. We will do the same thing for the zone 2 as well. So let's go ahead and do that. And again, if we go and look at the status of the zone, you can see that the zone 2 status is in incomplete. Very soon you would see the zone 2 also would be installed and then we only need to boot these 3 zones. Remember, these 3 zones are connected via private network. We haven't assigned the IP address yet, but these 3 zones are connected via private network, which is nothing but a stub that we created a few minutes ago. Just to help ourselves remember what is the address of the S11 server, you can see that the network address of S11 server is 0.100. You would remember from the diagram that we looked at when we started the session that S11 server and S11 desktop are on the same network with 0.x address. But the 3 zones that we have just created, which has the VNICs created from the stub, we're going to assign a different network address, which is going to be 1 dot, so that all of them can talk to each other. It's like a protected network within a single box. You could call this as a data center in a box, a complete network machine inside a box. Now that all the 3 zones are in installed state, which we can verify using this command, let's boot each of the zone. Zone ADM -z zone 0 boot. Again, if you remember from the earlier segment, right now if I go back to a terminal and I look at the status of zone 0, it would be in ready state. Ready is a state of the zone that's between the installed state and the running state. Once you've got your terminal back, if you say zone 0 is in running state, and the zone ID assigned to zone 0 stands at 5, that keeps changing, of course. Let's boot zone 1 as well. So zone ADM -z zone 1 boot. We will boot the zone 2 also, and then we will have to go through the system identification phase where we will assign the IP address of the zone. We would create users for the zone if required, etc. So we will boot the zone 2 as well. Let's see what happens. Once we have all the zones booted up, we will log into each of the zone to configure the zone with its host name, IP address, naming service, etc. Now let's look at the status of the zone. Except for zone A, all other zones are in running state. We can also look at show DLADM show-VNIC. Now you can see that each of the VNIC that we created on the stub has a zone associated with it. So because we have assigned VNIC 0, VNIC 1 and VNIC 2 to each of the zone, the status of the VNICs also showing that these VNICs are attached to a zone that exists on this machine. So we have it all ready. Now let's grab the console of each of the zone and then configure the zone. So let's say zlogin -c zone 1, or maybe start with zone 0. You get the console here. I hope you're familiar with this. Let's call it as zone 0 itself. We'll configure it manually, the network. I would say 192.168.1.100. Let's move forward. We don't want to configure a DNS. We won't configure a naming service. Let's choose Asia here. Let's go ahead and choose India here. That's fine. This is also fine. We'll configure a password for the root. Remember, we could also create a role account in case if you want to make the root a role account. So that zone 0 configuration is done. While that boots up, let's go to the other terminal and run the command zlogin -c zone 1. We'll configure the zone 1 as well. Let's call it as zone 1. We'll configure manual networking 192.168.1.101. We don't want a DNS, so let's move ahead. We don't want a DNS. Naming service is fine. Choose Asia. We'll choose India. This is fine. This is fine. Give a root password. So root is not a role account, it's a normal account. Let's give it. So that is also happening. We have the zone 1 ready here, in fact zone 0 ready here. Let's log into the console. we can look at what is the IP address of this machine, ipadm show-addr. Of course, that's the IP address 192.168.1.100. We can term is equal to vt100 export term, clear the screen, ping 192.168.1.101. we just brought it up, so you can see that zone 0 is able to ping zone 1. We can go to zone 1. We just completed the configuration of zone 1. Log into zone 1, verify what is the, we'll fix this display first, verify what is the IP address. We can try pinging 192.168.1.100 and see what happens. So you're able to ping these zones with each other. Remember, I haven't configured zone 2. I mean, it works the same way. Remember, to get out of the console, it's actually tilde dot. It's a little tricky to use. Yeah, so I've closed the console connection to the zone 1, and I'm back at the global zone here. If I try to ping 192.168.1.100, you can see that I'm not able to do that because the obviously it's a private switch to which all these zones are connected. Let me also go to the S11 desktop, exit. Let me see what is the, so this is my desktop. IP address is 192.168.0.101. let me try pinging 1.100. obviously that's not going to happen. Let's go back to the diagram. Again, what you can see in this diagram is that the machine from where I'm trying to ping zone 0 is in the 0.x network address, whereas zone 0 is 1.x. But we do have S11 server on the same network as the desktop, 0.101 and 0.100. So the point is, if you are able to make a router here, then I would be able to forward the packets of 0.101 to the machines that exist in here. So there has to be a router. Obviously, router is the device that understands multiple networks. So a packet from one network is forwarded to the target network by the router. So if you're able to configure let's say either the S11 server with one port of stub and configure a router here, I would be able to forward the packets from S11 desktop to the zones that exist. So what we will do is, let's pick up zone 2. We haven't configured zone 2 yet. We will go through the system configuration of zone 2, configure 1.x address. We will also let's say assign a port for zone 2 here from let's say net 2. We have a port net 2 on this machine. We'll assign net 2 to zone 2, and then we will configure an IP address 192.168.0.102. that means of the same network address as that of the S11 desktop and S11 server, and make zone 2 a router. So let me recap what I'm trying to do here. So in this case, you can see zone 2 will have a VNIC, which is VNIC 2, that is connected to the stub, that is from the stub. So zone 2 belongs to the network of all the 3 zones that exist in there. Zone 2 will also have one additional port that belongs to a network 0.102. In a sense, zone 2 would have IP addresses of both the networks, and as long as I'm able to configure zone 2 to forward the packets from either of these networks, zone 0 will be able to contact S11 desktop, S11 desktop will be able to contact zone 0. So let me recap this again. Zone 2, the configuration that's going to be done in zone 2 will have 2 ports. One is a port a VNIC from the stub, recognizing zone 2 to be a part of the 1.x network. I would also assign one more port to zone 2. That port is from the machine S11 server, and configure that particular port with a network address of 0.x. So effectively zone 2 belongs to both 10x network as well as 0.x network. Then after that, if I am able to configure zone 2 to just forward the packets to either of these machines, then via zone 2 S11 desktop can contact zone 0 and zone 0 can contact S11 desktop. Same is the case with zone 1 as well. So let's go ahead and do that. We will configure 2 ports for zone 2. Let me SSH to the S11 server and switch user as root. Let me list down the zones again. Zone 2 is running, but I haven't done the system identification in zone 2. Let me just shut it down because I want to add one more port to zone 2. So let's say zonecfg minus z zone 2, add net set physical is equal to net 2 and exit. So zone 2 has 2 ports. One is a virtual network port from the stub, the second is a net 2 port from the machine. Now let me boot zone 2. Once the zone 2 comes in running state, we're going to grab the console of zone 2 and start configuration. When we do that, we will have 2 ports to be configured. Let's log in to zone 2. Okay, we have the console of zone 2. I think we will keep the host name of the zone 2 as zone 2 itself. We'll configure it manually. Remember, now we have 2 ports for zone 2 because zone 2 has to be a participant in both the networks 0.x and 1.x. 1.x is for VNIC 2, so we'll go ahead and configure that first. Let's say 192.168.1.102. That's the we don't want to configure DNS. Naming service is fine. We will choose Asia. We will go ahead with India. This is also fine. Set the root password. So root is not a role account, and now zone 2 is rebooting. Meanwhile, I'll go to the other terminal and just exit out of the console here so that we can make use of this terminal as well. So we have come out of zone 0. In fact, unfortunately the tilde dot will take me out of the S11 server connection also, so I'm back at the desktop. What I will do is to SSH to the server again and switch user to root. Let me look at the command zone ADM list minus. So all of the zones are running. I can see zone 2 is up and running now. And let's fix the display. IPADM show-addr will show me only one IP address. I also have a net 2 port assigned to zone 2. Let's configure that. So DLADM show-link will show you both the ports. Net 2 is not configured yet. Let's say IPADM create-IP net 2. Now we look at DLADM show-link. The state of the link net 2 is up. Let's configure an IP address. IPADM create-addr -t static -a192.168. It's going to be of the network address 0.102 net 2/v4. In case if you are not very familiar with these commands, in case if you're not able to recollect these commands, it would not be a bad idea to go back to the Solaris 11 documentation around networking, or I also have a video created around Solaris 11 networking which you could quickly look at. So now zone 2 belongs to 2 networks. One of course is the 192.168.1 dot series, the second is 192.168.0 dot series. What I'll do now is let's say open a terminal. So I'm on the S11-desktop now. Let me find out the IP address of S11 desktop. As we observed earlier, it has an IP address in the network 0.x, and now zone 2 has an IP address in the 0.x network. So let's try to reach zone 2 from this machine by using the ping command 192.168.0.102. that is the IP address we configured on the net 2 port of the zone 2. So no prices for guessing that we are able to reach because it's in the same network. Since I'm able to reach zone 2 using this IP address, I should be able to reach out to zone 2 using 1.x as well, because it's anyway going to send the packet to zone 2, and the zone 2 has the 1.x IP address configured in it. So let me try to ping zone 2 192.168.1.102. So I'm pinging zone 2 using the other IP address that zone 2 has. Remember, this IP address is configured on the VNIC2 of zone 2, which happens to be the VNIC configured on the stub. Again, I'm able to reach zone 2 using 1.102 IP address because zone 2 has an IP address that is configured in the 0.x network. So it's accepting the packet, and since the IP address belongs to it, it's responding back to this machine saying that yes, I am alive. But what I would also like to do is to try and reach zone 1 and zone 0 from this machine. Remember, zone 0's IP address is 1.100 and zone 1's IP address is 1.101. Let's try and do that. This is my zone 1. I'm not able to reach zone 1 from this machine. Let me try zone 0. I'm not able to reach zone 0 from this machine. We'll go back and look at the diagram one more time. The situation that we are in currently is 0.101 machine is able to reach zone 2, of course using 0.102 because zone 2 has the IP address 0.102 configured on net 2 port. It is also able to reach 1.102 address of zone 2 because zone 2 accepts the packets from 0.x network, and since zone 2 identifies the packet 1.102 to belonging to it, it accepts it and responds back to the desktop. But what is not happening here is when 0.101 machine tries to send a packet to 1.100, obviously the packet is reaching zone 2 for sure because zone 2 accepts packets from the network 0.x, but it simply is not responding back or doing anything with the packet because it's not responsible to do anything with the packet. If I am able to configure zone 2 as a router, in the sense that if I configure zone 2 to forward the packets that it receives, probably I should be able to reach zone 0 from the machine S11-desktop. So the way it would happen is if I try to ping zone 0 from S11-desktop, the packet anyway would reach zone 2 because it accepts the packets from the 0.x network. It observes the packet to be the one that is not targeted to it, but since it is entitled to forward the packet because we configure zone 2 as a router, it will forward the packet to the other two zones that exist in the network. So again, if it sounded a little complicated, let me recap it again. I am trying to ping zone 0, that is 1.100 from S11-desktop. Of course, the packet reaches zone 2 because zone 2 is configured to accept packets from the 0.x network. It figures out that the packet 1.100 does not belong to it. If it is not configured to forward those packets, it will simply drop it, which is what is happening now. But if we go ahead and configure zone 2 to forward the packets, then the packets that does not belong to it, it will forward the packets to the network 1.x. Once the packet is forwarded to the other machines in the stub obviously zone 0 and zone 1 would pick it up, and if it belongs to it, it will start responding, and again it will start responding through zone 2. So effectively zone 2 is acting as a router here. Of course, the term router is not just forwarding the packets, there are a lot more to it, but in this case we would loosely use the word router. So we're going to configure zone 2 as a router simply by enabling forwarding for the IPv4 protocol, and once we enable forwarding in zone 2, we will see if S11-stub is able to contact zone 0 and zone 1 through zone 2. So let's go back to our machine zone 2 here. We have the zone 2. Let's look at the property -p forwarding for the protocol IPv4 and see what is the current status. As you can see, forwarding is disabled in zone 2. I'll go ahead and enable it. Set -prop -p forwarding is equal to on for IPv4. We will verify whether forwarding property has been set to on. Now it is on. Let's go back and see if we are able to ping 1.100. As you can see, this is zone 0. We'll try and ping 1.1. That's zone 2. We can use a command trace route to figure out what is the route it is taking to reach zone 0 there. As you can see, it first hits the zone 2 with the address 0.102, and since zone 2 is configured to forward the packets to the 1.x network, it forwards the packet from its machine to the other machines in the stub. We can also log into zone 0 and try pinging 192.168.1.101. Remember, this is that S11 desktop that I'm trying to ping. You can see that I'm able to ping, in fact, sorry, this is the wrong network address, 10.101. You can see again, I'm able to ping a machine that belongs to a different network, 0.network, and if I try to do a trace route on 192.168.0.101, again you can see that it's actually going via the zone 2. So zone 2 is effectively acting as a router in this case. So to quickly recap what we did in this particular segment about zones, we configured zones using an existing zones configuration file. Next, we went ahead and installed the zone, but this time around we installed the zone not from the image packaging system repository, but we installed the zone by cloning an existing zone, and we observed that process to be faster than downloading the packages from the image packaging system. Then we went ahead and booted the zone and performed the system configuration, and while doing so we configured the VNICs of a stub to be the network ports for each of the zone that we installed and configured. Then we assigned a second port to one of the zones so that the zone could belong to two different networks, 0.x and 1.x, and we went ahead and configured that particular zone as a router by just enabling the property forwarding for the IPv4 protocol, and you were able to see that the 0.x network machines were able to contact the 1.x network machines in the stub, and 1.x network machines were able to contact 0.x machine using the zone that had two network addresses configured, as well as forwarding for the IPv4 was enabled. I hope this segment was useful for you to understand how we can configure VNICs on stub and assign those VNICs to the zones, and most importantly how we can provision zones faster by using the cloning operation and also the IPv4 forwarding property. Thank you so much for watching this segment.